Today we have guest Kristinn Ingi Lárusson, who is the head of business development for Carbfix. Carbfix has been one of those companies that I've been watching since day one, and I've been very excited about all the things that you are now doing. So for our audience, just talk a little bit about what is Carbfix, what is this company about?
Yeah. So Carbfix is an Icelandic company, was formed as a corporate in 2020. Before that, it was a research project. Originally dates back to 2006-07 when 3 universities came together: University of Iceland, Columbia University in New York, and CNRS out of Toulouse in France, with the purpose of checking out if they could, replicate Mother Nature's way of storing CO2 in the bedrock. This project was then hosted by, Reykjavik Energy until it was incorporated in 2020. So it is truly a project that is based upon science. And again, the scientists at that time were kind of surprised in an extremely positive way how quickly they managed to, replicate Mother Nature's way of storing by mineralizing the CO2 in the bedrock. So instead of this process happening in thousands, if not hundreds of thousands of years, this actually happens in less than 2 years.
What are the main ingredients for able to replicate this? What do you need to have?
So in Iceland, we are very rich in basaltic rock. So basaltic rock is one. The second is water. You need water, lots of water. And the third one is CO2. So once we, dissolve the CO2 in water, we inject it as a sparkling water into the bedrock, where the bedrock receives the CO2. The mineralization process starts to take place. So in a very simple analogy, we can say we are using the water as a means of transport for the CO2 into the bedrock. We drill wells that are, let's say, on average 500 meters deep. And then once we inject the dissolved water in, the chemical reactions of the bedrock take place. So the cationic ions, calcium, magnesium, and iron, they get released. And the water floats its own path, and the CO2 jumps off the water and starts to mineralize into
the basaltic rock.
Yeah.
Obviously, we have plenty of carbon now because we've been putting a lot of carbon into the atmosphere. The big idea around mineralization of carbon came from research from universities. Obviously, carbon sequestering has been one of those topics. And that's how I got interested in that research. And I'd moved just to Iceland in 2006. So I was very excited about the work that was going on. But obviously, these things take time.
Yes.
So it has been almost 15, 16 years for it to come to fruition. So talk a little bit about how are you all thinking about scaling this technology? I mean, obviously, Iceland has both the basaltic rock. It has plenty of water. Iceland sits in... We have 2 big glaciers, so we have perennial water source. How do you do this outside of Iceland? I mean, what is the methodologies that you're thinking about in terms of scaling this?
It's very clear that the issue that we're facing today, it's a global problem. So one of the biggest problems we are facing today is the climate issue, and the Paris Agreement kind of emphasizes the fact on that. So it's estimated by the International Energy Agency that, for example, we will need to avoid approximately 1,000 billion tons of CO2 if we're going to achieve the set goals of the Paris Agreement. Within that 1,000 billion tons, which is a huge number, it has a lot of zeros, about 12% or 120-ish billion tons will be under the so-called carbon capture, utilization, and storage. That means, doing e-fuels and so on and so on by the utilization of CO2. But out of these 120, I would say 95% fall under the storage part. So it is a global problem that we're facing, and we have a lot of solutions out there. It's about embracing them and having them, materialize them. We have one solution, so we don't claim we have the silver bullet, but it's just definitely one solution that people should look at. So in our case, basaltic rock is one of the 3 ingredients that we need. It happens to be that in Iceland, basaltic rock is very, let's say, it's a resource that we have, just like water. But furthermore, about 5% of all land on Earth is covered in basalt. Additionally, on top of that, about 70% or 70% of the ocean floor is covered in basalt. So the potential for utilizing this technology, Carbfix by mineralization storage, is not limited to Iceland. It's a global solution because basaltic rock is in every continent. There's quite a lot in Europe. There's quite a lot in the North America and South America, Africa, Asia Pacific, and Australia and New Zealand. So it literally is everywhere. So our ambition when Reykjavik Energy decided to form Carbfix as an enterprise, it had 2 ambitions: A, scale up, and 2, to commercialize the idea. So right now, where we are simply starting our voyage. We have been recognized as a new technology with great potential. But the problem is we're all facing is that time is of essence. So we have to act right now.
Right.
Our ambitions are huge,
Right.
but we will not do that by ourselves. So we need partners. We need partners on a country basis, a regional basis, and global basis.
Right.
And that's how we envision to scale up. So we are currently working on projects across the globe. We have quite a few projects in the Asia Pacific region. We have quite a few projects in Europe, the same as in North America. We even are starting working on projects in Africa additionally. So we believe that we have a solution that can benefit the globe to a global problem.
Right. I mean, you talked about commercialization. Talk me through what is the business model? How would somebody who wants to use this technology engage with you?
Let's assume that you have that you're a producer of cement, which falls under the so-called hard-to-abate sector. Let's say that you're an international cement company and you have facilities in 80 countries. You have 100 facilities. So this particular company perhaps would know about us and they would approach us. We have on our website, carbfix.com/atlas, an open source atlas map that allows you to come in and look at and see, okay, I type in where I am located or my facilities, and it gives you a clear indication whether you have the possibility of utilizing or exploring further your possibility. So in this case, a cement facility, let's say that you're in the middle of, you have a facility in state of Washington in the US. You type that in and you see that there is a yellow color on the map. That's an indication that there is basaltic rock there. So under that circumstance, we would need to understand more about the subsurface. So there you approach us, and our first step in the process is to do a study, is to do a desktop study. We call that level 1 study. Once you have gone through the level 1 study, you know more and you're more confident to lead to a level 2 study, which gives you a more kind of a pre-feasibility analysis on the subsurface and that particular facility. If there is still a thumbs up, you go to a full feasibility analysis. So you have these, in first phase, you have 3 studies that but let's say the certainty that you're going through a funnel, and it is kind of risk mitigating, understanding the geology, understanding the subsurface, and so on and so on. So once you have done all these 3 studies, you are in a position to say, okay, we can go for a pilot or not. And then you reach stage 2, which is sort of pilot stage / EPC. So where your engineering, procurement, and commissioning. We would assist you in that. So we can follow you through from, let's say, cradle until grave. So, and once you have built that and the pilot is successful, you can build a commercial site, or we can assist you with that and build it. And then you go into a full operation by injecting CO2 into the bedrock, and we receive certain fees for that. Obviously, within that paradigm, the phase 1, phase 2, and phase 3 are different, and it takes time. This is not something that is built overnight. This is usually, we're assuming, somewhere between 3 and 7 years in full process. So our business model is to receive a certain, we can say, gate fee once we receive the CO2. And that gate fee depends on under what scheme that is. If it is under so-called mandatory scheme, which is in Europe, and then you have another scheme we call voluntary scheme, which is a totally different pricing. So this industry is in its infancy. So is our business model. We know for sure that in a year's time things will be different. We know for sure that in 5 years' time will be totally different. But right now, this is how we work. We will receive a certain, let's say, fee for the studies, and then we will receive for each, let's say, project, every ton that is injected, we receive a gate fee, and so on and so on.
So you're not looking at pricing carbon or looking at the carbon saved as a metric, because there's a pretty established market now for that.
Yeah, there is again, there are two schemes here. We can say in Europe you have the so-called ETS scheme, European Trading Scheme for Carbon Credits. That's a market that's open for trade and so on and so on. Currently, each ton is sold for approximately 80 euros per ton. But then you have the voluntary market, which the sky is the limit, and we know for sure that some carbon credits have been sold to up to $2,000 per ton. So there's a huge difference between. Our business model, yes, we are facilitating that at one point in time that we will be able to sell carbon credits, but that's within a limited scope. So first and foremost, we are offering a service, but again, emphasizing on the fact that what we're doing today will most likely not be exactly the same in a year's time, and certainly not in 5 years' time. It's developing.
Very cool. Tell me a little bit about the opportunities in India. Obviously, that's close to me, and also one of the big. When the president of India was here, we came and visited, and there were a bunch of people from India. All of them were very eager to get started and started working with you all. So tell me a little bit about India and what is going on there.
I mentioned before that there are 3 ingredients that are needed for the Carbfix solution or technology to materialize. Obviously, basaltic rock, water, and CO2. We know for sure that water is a scarcity in various parts of the world, and definitely in India. But we also know that India is very rich in basaltic rocks.
Right.
So there's huge areas in India that are truly exciting from that aspect, and there definitely is a lot of CO2 there, emission. So we define India as one of our tier 1 markets. So we have defined certain countries in Europe as our tier market. Certain, let's say, North America as a tier 1 market, and certain states within the US. And then in the Asia Pacific region, India is definitely, as well as Japan, South Korea, and so on. So, but India being extremely interested, and we are hopefully about to start a project there or a study. We have been in dialogue with quite a few companies there. So the potential is huge. And you can imagine once we have unleashed the riddle on whether we can use actually seawater instead of using regular water, because as I said, water is of scarcity in various places. So what we are doing right now, and we just started in Iceland about 10 days ago, we started in Helguvík, next to the Keflavík airport, injecting seawater, using seawater instead of regular water. And we have done, our science team, particularly Martin Voigt, published a paper on from a laboratory point of view. So that report and a paper was very positive. So now we are actually doing, on-site in-field injections. So once that we have kind of unleashed that, you can imagine 70% of the ocean floor is covered in basalt. That means that we can actually use seawater, offshore, near to shore and onshore. So that opens the possibility to utilize the technology in a much greater manner in countries like India. So the potential there is enormous.
Yeah, it's a game changer if you're able to use the seawater, because obviously there's plenty of it, and obviously the world is covered with water and sea. And tell me a little bit more about this big project that you're doing up north in Iceland. This is a European Union grant that was, I think I heard it was probably the largest grant ever given to Iceland. Talk me through some of that.
Yeah, so that is a project we call the Coda Terminal, and the Coda Terminal is sponsored by the European Innovation Fund. So this was a new initiative that was launched in 2020 in the fall. That was the first time they actually opened for applications. We did apply for that in September 2020. We did not receive the funding for the first attempt. So we kind of rethought how we would approach it, and the second time we applied in early 2022. We got a response from the European Innovation Fund in July 22 that we did receive the funding. So that funding amount was about 115 million euros, or about 18 billion Icelandic kroners. Which is a significant grant, and I think, yes, that's correct. It is by far the largest grant an Icelandic company has ever received. That project entails that we are building the world's largest mineral storage site. That will be actually next to Straumsvík, here in just in the capital region. So that we envision that when the operation will be in full, let's say, capacity, it will be able to receive approximately 3 million tons of CO2 annually. And we foresee that that project will be for over 30 years. Of course, we are bound by rules and regulations, and right now we are doing the so-called environmental impact assessment. So we are bound by all the rules that the environmental agency sets. So this is just a process. So we are in a preparation phase as we speak right now.
So if I understand that correctly, Iceland will receive carbon, and we will basically inject it into our basalt rock and store it for the world.
Yes, so in this case, of course, this is a new industry. So the idea behind the European Innovation Fund is that they have set up a mandatory system in Europe. So every country within EU and EEA falls under that scheme. So there are, each emitter within certain industries there are set rules. So you either, you have to commit to these programs. So in short, it's like a quota system. So it means that if you, let's say, for example, if you emit 1 million tons per year, this government will give you, let's say, you will get a 900,000 free card, but you will have to pay for 100,000. Either you can buy it in carbon credits, or you can initiate a new technology that lessens that lowers the emission. And this the free card lowers every year until 2050. And then that means that as time moves along, your commitments are greater and greater. So it kind of pushes the companies to be initiative in thinking, either to create new technologies, or you can simply buy the carbon credits. And the funding of this scheme, the European Innovation Fund, is funded by the ETS system. So the proceeds from buying the carbon credits are awarded to projects like ours.
Right, okay.
So we did receive 115 million, and the idea is to receive CO2 from various emitters across Europe. So the business case in that is based upon that we will receive CO2 at the harbor in Straumsvík, where we will receive it, and anyone that brings it in will pay a certain gate fee. So that's how we fund that. But in this is a new industry, so that means that there's so many things on the value chain that need to be looked at. Again, there are, who is going to be the emitter? Where is the emission from? What type of an emission is it? And we've been very adamant within Carbfix to be, we say we want to focus on certain industries. So those industries we believe are in most need are defined as the hard to abate sectors. The cement, the steel, the aluminium, and the industrial chemicals. Those are the ones that have the most difficulty in doing transformation in their processes in this energy transition. So that's where we're focusing on. But again, obviously, this needs to go through certain, the rules and regulations here in Iceland. So the idea is for us to receive the CO2 in a liquid state at the harbor in Straumsvík, where it will then be gasified and then dissolved in water and injected into the bedrock, just like Mother Nature does. So we are simply replicating what Mother Nature has done for millions of years.
Right. I mean, this is very progressive, and it's actually quite innovative, but it's also very fundamental how the chemistry works. So tell me a little bit about the Xprise, because you guys were also recipient of the Xprise, if I'm not wrong. I don't know if it came first. I think Xprise came first, and then the grant from European Union came.
Yes, that might be. I think we kind of submitted our application at the same time almost. So it was very, very good. So the Xprise is Elon Musk. He committed to give out $100 million to one company. So in short, there are 10 companies or 10 projects that were chosen that are competing for this $100 million. All of these 10 projects received $1 million. Out of we did receive 2 out of the 10. So we have 2 projects out of the 10 projects, which is of course we are extremely proud of what we do, and our I have to emphasize our team is just fantastic people. Not only most clever brains on earth when it comes to these.
Very mission driven.
Oh, so absolutely, it's such a pleasure, and I always say that I go truly excited to work every day, and I come home extremely proud because we are doing something. So, going back to the Xprise, this of course is a very interesting prize because it is from the direct air capture. So we are working with 2 companies there that received it, Vertox and Helum, and it's a totally different market than the mandatory market that I was referring to for the European Innovation Fund. So it's more like the voluntary market. We are operating an injection site for our partners at Climeworks at Hellisheiði, which is the world's first direct air capture facility and mineral station storage. So that's the world's first. So we are pioneers when it comes to this. And so now we of course DAC is one of the let's say the focus areas that we are looking at. So we have defined these C7 industries, and DAC is definitely one of them, the 4 I mentioned before, the hard to abate, and then we are looking at BECCS, the bioengineering, carbon capture and storage, and geothermal.
I mean, in the direct air capture, which is a facility that you operate in Hellisheiði,
yes.
So what is the size of that, and how much carbon do you capture now from the air?
So we are not, Carbfix is not capturing the CO2, that's Climeworks. Climeworks. So Climeworks is capturing, they're capturing at the Orca site 4,000 tons per year. But that is a huge amount. If you think about it's a new technology, it's a first of a kind. So even though 4,000 tons is a very, very tiny number in the compared to the 120 billion tons I was referring to earlier, it's you always have to take the first step. And Climeworks definitely have done that. They are the only commercial operation so far. So we are receiving it and dissolving it in water and then injecting it into the ground. Actually we do it simultaneously. So what is happening at Hellisheiði is that Climeworks is actually scaling up. So they're building a second plant called the Mammoth. Mammoth is actually 9x the Orca, so 36,000 tons that will be captured from the ambient air, and then we will dissolve it and then inject into the bedrock. So it's a technology that's taking its first steps, but at the same time, it's a very, very interesting technology because it is, capturing directly from the ambient air. And as we know, and I mentioned before, that it's a global problem.
Right.
The emission that will be, polluted out in let's say in China today will probably be in Iceland in 6-7 days.
Right.
And vice versa.
Right.
So it's not limited to China, Iceland, or any other country in the world. It's a global problem.
It is a global
so we have to address that accordingly.
Right. So what do you need to do to win this Xprise, the 100 million? So what's the goal?
Well, we of course are again collaborating with
Right.
strategic partners like Hellum, like Vertox, and others. So we will of course continue our voyage, and we have been very clear that we can say Carbfix 1.0 is as we are right now. Maybe Carbfix 2.0 will be able to use seawater. Carbfix 3.0 will be able to use other rock formation than simply focusing on basalt, and so on and so on. So we will have to continue develop our, let's say, and be innovative. And I can assure you that our fantastic team, of scientists, they are there. We have, so much clever people there that are continuously and driven by the fact that we need to do something more.
Right.
We will not stop. We will continue.
Right. What is the size of the team right now? How many people are working on this?
It's a tricky question. We are growing.
Right.
So as a company, when we started in early 2020, we started 5. Now we are approximately 50.
50.
So we've tenfolded in 3.5 years. So it's a fantastic group of people, very diverse. We have, I think, 12 different nationalities. All of them are working in Iceland except one person working from France. But we are super excited. We have high ambitions. We are driven by the fact that we are contributing to the globe. We've set ourselves, of course, ambitious goals in regards to targets of injected CO2 in the coming years. But we will achieve it. But we will achieve it with our partners. I think that's kind of and just the mindset of the people.
All right, Kristinn, that was wonderful. Thanks so much for sharing the story of Carbfix so far. There's lots of people cheering you on to see you succeed in this challenge, because I think we need all these innovative solutions to happen. And thanks for spending the time with us.
Thanks for inviting me. It's been a pleasure. Thank you so much.
Yeah, wonderful.